When we hear a lot about machine learning models these days, like ChatGPT, we may wonder, what does the word model exactly mean in machine learning? A machine learning model is essentially a special kind of computer program or code that can learn from data to perform a task. The task could be making predictions, decisions, or generating something new, like sentences, images, audio, etc. For instance, ChatGPT can generate new sentences, and DALL-E can generate new images. Any task is essentially a model taking in some input and producing some output. Once a model has learned from a set of data, it can then use what it's learned to perform tasks on new data. However, it does best when the new data is similar to what it's been trained on. The things models learn from data is typically stored as numbers in models like ChatGPT. These numbers are called model parameters. ChatGPT-like models have at least 100 billion parameters. It is in a sense similar to how we store knowledge and experiences in the connections between the neurons in our brain. Even though the model code is written by programmers, programmers do not code the solution to solve a task. Instead, they code functions and algorithms that can learn from data to solve tasks. For instance, ChatGPT has a complex function that accepts a text prompt as input and generates new sentences. The complex function is organized as layers of computation, transforming input to the desired output. The way these functions are designed, with different layers of calculations stacked upon each other, is often referred to as the model architecture. ChatGPT's model architecture is made up of billions of parameters that are updated by a learning algorithm during training. Once the model is trained, we can use it to solve tasks by prompting it with our task description. There are different ways for a model to learn from data, as we saw in the previous video on what is machine learning. One approach is to learn without any human assistance. Another way is to learn with some human assistance. A third approach is to learn with occasional rewards. Some models learn using a combination of these approaches. For instance, ChatGPT first learns without any human assistance. It learns on its own from a large number of sentences by trying to predict the next word in a sentence. This step is very similar to how children learn about the world on their own, even before they can talk. We saw an example of this in the previous video, how a clever experiment shows children know gravity even before they can talk. They learn on their own by predicting what is going to happen next in the sensory input streams that flow into their brain. ChatGPT then goes through a second round of learning, but this time with human assistance. This step helps the model output responses that matches the intent of our questions. And finally it learns with rewards received based on the quality of its output. The final step helps the model learn to output quality responses to our questions. The choice of a model for a task depends on many factors, such as the nature of the task we want to solve, the data that is available to train the model, the cost of training, etc. Although any task where both the input and output is text could in principle be solved by a model like ChatGPT, there are some benefits to solving some text in and text out tasks with specialized smaller models for a variety of reasons. For instance, if we have data on the pricing of houses, along with features of the houses, like number of rooms, location, etc., a simple, small model that can output a price, given the features of the house, may be easy to train on our data and potentially have the best performance. There are a wide variety of models suited for specific tasks for us to choose from. The specific category of models, called neural nets, have become increasingly popular because of their ability to learn important features automatically from data and solve tasks. Neural net models can solve tasks with performance levels matching or even surpassing humans, especially when the data to learn from is large. Neural net models utilize the concept of a stacked architecture that we discussed earlier, where calculations are performed in layers stacked on top of one another. Large neural nets are complex functions several layers deep and made up of learnable parameters. These functions, as mentioned earlier, transform input to the expected output after training. The training process of any neural net model, regardless of the learning approach, is the same. During training, the model is fed in some input. The model's output is compared with the expected output, and the error is then used to tweak the model parameters so that the error in the prediction is reduced. The calculation of the amount to update each model parameter to correct for prediction errors is performed by an efficient algorithm called backpropagation. The actual process of updating the model parameters by a small amount in the direction that minimizes the error is performed by an optimization algorithm called gradient descent. Once the model is trained, the model parameters are no longer changed. The model is then evaluated on data it has never seen during training. The result of the evaluation is used as a metric of model performance. It essentially is a measure of how well the model is likely to do on data that it has never seen before. The model is now ready for use on the task we trained it to solve. We typically call this inference mode to distinguish it from training mode. There is a big difference between how we learn and how models learn. We can learn on the fly. That is, we can learn new things while doing a task. Current models cannot do that. They are two separate stages. The first stage is the training stage, where the model parameters are updated as it learns. This is typically a slow and compute-intensive process. It requires a large number of examples that is fed to the model in batches for the model to learn from. And the second stage is the inference stage, where the model parameters stay frozen, and the model makes predictions based on what it learned in the training stage. This is the reason why GPT-4 says it cannot answer any question that requires knowledge after September 2021, the cutoff date for data it was trained on. It has no knowledge of the world subsequent to that date. We would have to train a new model, including the new events that happened after that date. In the videos to come, we will examine in greater detail different model architectures best suited for different tasks, and how a model actually learns from errors.